Hi everyone, welcome back to Array series. Hope you are doing good. In this video, we will look into Leetcode problem number 11, container with most water. So this is a very famous problem which is being asked in many companies. With that, let us try to look into the statement of this particular problem. So you are given an integer array, height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are I comma 0 and I comma height I. Find two lines that together with the axis x-axis form a container such that container contains the most water. Okay. Return the maximum amount of water a container can store. Note that you may not slant the container. So you may not slant the container. It means the water which gets stored will be like a rectangular shape. Okay, so they have given this particular example. They have given multiple examples here. So in this one, if you see, between this particular line and this particular line, we can store the most water. So we need to find what is the area of this particular blue rectangle and we need to return. So they have given few constraints like n will be height dot length, okay, basically the length of the array, and the value of n will be between 2 and 10 raised to 5. Okay, there will be minimum 2 values given in the array, and any value in the height array will range between 0 and 10 raised to 4. Okay, with that, let's switch to our editor and let us try to understand this problem in detail. Okay, now they have given this particular height, okay, and this is of height 1, this is of height 8 and 6 and so on, correct, right? I have drawn the heights in a graph here. Now if I consider this particular line and this particular line, what is the maximum amount of water I can store? So I can store water till here, right? This is the maximum amount of water I can store between these two lines. If I try to fill more, it gets overflowed. It gets overflowed. So it means if I want to find this particular area, I need the minimum height between these two lines and the distance between them, correct, right? Because this is a rectangle, right? If I find the area of this particular rectangle, then I got the quantity of water these two lines holds. That's the maximum quantity of water that these two lines hold. Okay, so we need to check between these two lines, we need to check between these two lines, we need to check between these two lines, and we need to check between all the possible lines, and we need to find the area, and then we need to take out the maximum out of it. So that is what is the problem states here. Okay, and also we have already seen the constraints here. Okay, with that, maybe you can pause for a second and you can think for any possible solution and then come back to the video. Okay, now let us try to understand what interviewer will be looking at you by giving this problem. So basically he wants us to solve this particular problem in a most optimal way with O of n time complexity and O of 1 space complexity. Okay, let us see how we will arrive at that optimal solution. So for now, let us try to understand the brute force solution for this particular problem. Okay, now as I was saying, if I want to find the maximum water between this line and this line, then what is required? The minimum height between this line and this line, so which is 1 in this case, and the distance between these two lines, So distance, how you can find? You can simply subtract the greater index with the smaller index. Okay, with that you can find the distance between those two lines. So now if that is the case, let us write our formula. Area equal to minimum of height 1 comma height 2. Okay, this is one line and this is another line, into distance between them, distance between the lines, This is basically, we will try to derive furthermore. So how we can do, min of height is our array, right? Then maybe we might take 2 indexes. So this j will be our second index, comma height of I, which is our first index, into j minus I. Okay, so this gives the distance between both the lines, and this will give the minimum value. Okay, with this formula we can easily find out the area. If that is the case, now what I will do, I will find the area between these two lines first, then between these two lines, then between these two lines, and so on. I will try to find until the last line. So with this, somewhat we might get max value or we might not. Then again we have to start with the next line. From here we need to find what is the maximum rectangle area between these two, then again between these two lines, then again between these two lines, correct, right? And somewhat between all the lines. So this I need to do by taking this height first, then this height, then this height, then this height, then this height, and so on till I finish all the lines. Okay, with that, now let us try to see how we do that. So now I will take this particular array. Now I will take these two values and I will find. So area, first I will take one value area, then I will take max value. Okay, I will keep updating this max value whenever I get a maximum value. So between these two, what is minimum? 1 is minimum, correct, right? Into what is the distance between these two values? Basically this is 0 index, 1, 2, 3, 4, 5, 6, 7 and 8. So if you find the distance between those two, 1 minus 0, so it is 1. So my area will be 1. Okay, initially max will be 0, now I get 1, so I will update this with 1. Now repeat the same between this and this value, 1 and 6 now. So minimum is 1. So here one thing what you can observe, always we consider the minimum value, correct, right? So if that is the case, here 1 is the least possible value. So in all the cases it will be 1, only the distance will keep changing. Initially it will be 1, then it will be 2, so it becomes 2, then I will update this with 2, then with the next value it becomes 3, then I'll update this with 3, and so on. For the last value it is something like 1 into the distance is 7, so max will be 7. So this is by comparing with this particular first value. Now I will repeat that with the next value. Okay, now I will remove this part. Now if you see, I have 8. Okay, I have done already this with 1, so there is no need to do it with 1. So I will only consider the further values. Now out of 8 and 6, minimum is 6 and distance is 1. So max area is 6. So already it is 7, so I don't update. Next one, 8 and 2. So between 8 and 2, 2 is minimum. So 2 into 2, it is 4. So again I don't update. Next 8 and 5. So minimum is 5. So 5 into 3, it is 15. Now I will update. And we need to keep on doing the same. Okay. So with this explanation, and we will anyhow update this. Now whenever we come across this particular 8 and this particular 7, the minimum will be 7, right? And the difference, the distance between 8 and 7 is 8 minus index of 1, so which is 7. So 7 into 7, so 49. So we will get 49 as the maximum area. So this we need to return. Okay, for that let us try to write the pseudocode. Now what I did, I started with one value and then I iterated over the remaining values. Next I started with second value, I iterated over remaining elements. Next I started with next value, then I iterated over remaining elements. So what I am trying to say is basically we use two loops. Okay, so let's take a variable max and initialize it with 0. Okay, and n equal to height dot length. This gives the length of the array. Okay, now let us take a for loop for I equal to, or maybe what we can say for simplicity, this is our left height, left equal to 0, left less than our n, then left plus plus. Okay, now what I will do, I will take another for loop and I will call it as right value. Then it starts from left plus 1, left plus 1, because always if I start here, then if I start at this particular one, then I started with this value, right? And then I proceeded further. So for that reason, I will say right equal to left plus 1, right less than n, then right plus plus. Okay, so now what I will do, I will take a variable area, then I will say min of height of left comma height of right. Okay, this will give us the minimum value. Then I will simply write below into then what I need, right minus left, correct, right? This gives us the distance between both the lines. Then we get the area from this. Now I will simply update my max with max of this max. Basically, I mean, we will use math.max here. So let's not have confusion. Math.max of max comma whatever the current area we have calculated. If this is greater, then I will simply update this max. Okay, with this, at the end, what I will do, I will simply return max. Okay, so now if you see, for each value, it almost iterates for n time. So it is not n time, basically one value lesser than the previous value. So basically what I'm trying to say is, if initially this iterates for n time, this iterates for n minus 1 time. This if the first loop iterates for n minus 1 time, then this iterates for n minus 2 and something like that. Okay, so somewhere the time complexity is of order n square. Time complexity is of order n square, and space complexity is of constant space. Basically, we are not using anything extra. So this is the extreme brute force solution for this particular problem. Let us try to execute. Let's take a variable int n equal to height dot length. Okay, after that what I will do, I will take another variable max and I'll assign this with 0. Now I will use for loop for int I equal to 0 or left equal to 0, left less than n, left plus plus. Then I will use another for loop. This time I will use right, and it starts from left plus 1. Okay, then right less than n, right plus plus. Now I will take int area equal to math dot min of our height of left comma height of right. It will take the minimum out of these two values. Okay, there is something wrong. I need to put it outside. Then I need to multiply this with right minus left. So this will give us the area. After that, what I will do, I will say max equal to math dot max of area comma the current max. Okay, if I do that, then finally I can return my max. Now I will run this. If you see, our solution got accepted, but if I submit, it will give us TLE because it is of O of n square solution. And if you see the constraint, the length of array will be 10 raised to 5. So it means, I have already explained that in earlier videos, our Leetcode won't accept O of n square solution if the length of the array is greater than 10 raised to 5. Okay, so let's improve this solution. So let's go back to this particular diagram. Let us consider using two pointers technique. Okay, so what I will do, I will point one pointer to this particular first value and another pointer at the last height. Okay, so I will start from here. Now what I will do, I will try to find the area between this line and this line initially. Okay, so if that is the case, since this is the minimum value, if I try to find the rectangle, then it will be something like this, correct, right? So this is the minimum value. That's why we will take this minimum value out of this line and this line. Now we consider the distance between them and we try to find the area. Okay, now if I consider this line only, now if I want to shrink this size of the array, is it good idea to eliminate this larger height or eliminate this smaller height? So I say we should eliminate this value because this is the maximum possible rectangle that we can draw if we consider this particular value. Why? Because since this is minimum, whenever you compare this with any other heights, always this will be minimum, right? Only thing is the distance will be changing. So now initially you are already considering for the farthest possible height. So it means that is the farthest, that is the maximum rectangle that you can formulate using this particular height, correct, right? Now you check here, since it is of unit height, I mean it is very easy for us to understand. So if I try to find the rectangle, this rectangle, the distance is 9 minus 1, which is 8, and height is, minimum height is 1. So its area comes somewhere 8, right? Now if I want to eliminate this height and if I want to consider this next height, and if I try to find the maximum rectangle, the minimum value is still 1. But if you see the distance, it is getting reduced, right? If that is the case, now area becomes 7, which is less than 8. So there is no point in considering the lower value, right? I mean, we want the higher value. So we are trying to increase the area of the rectangle. So in that case, I will eliminate this lower value. So this is what is the technique here. This way, I mean, we can improve the time complexity here. So if I eliminate this one, because whatever the maximum possible value that I can find using this minimum value, that already I have found out. So I can eliminate this and I will move to the next height. So I will increment the if the left side is lower value, I will increment left pointer. If right side value is lower value, I'll decrement the right side pointer. Why? I am trying to eliminate the lower height, because lower height will always give you lower area if you try to compare this with the remaining heights. Okay, keeping that in mind, let us try to see this example. Again, what I will do, I will take this array. So now what I will do, I will keep a left pointer here and I will keep a right pointer here. Okay, so we already know the indexes 2, 3, 4, 5, 6, 7, 8. Okay, so now what I will do, I will take area, then I will take again a max variable. Now if you check the area, what is the area? The minimum is 1, right? Out of 1 and 7. So out of 1 and 7, minimum is 1. Okay, so what is the distance between these two? It is 8 minus 0. So it means it is somewhat 8. So I will take that minimum value is 1 into distance is 8. So the area is 8. Since it is 0, I will update it with 8. At this particular point, my max value is 8. Okay. Now after this, I will check whether the value at the left pointer is lesser or value at the right pointer is lesser. So if value at the left here, the value of the left pointer, value at the left pointer is lesser. So what I will do, I will eliminate this value and I will move my pointer to the next number. Okay. Now between 8 and 7, what is minimum? 7 is minimum into what is the distance between 8 and 7 now? It is 8 minus 1. So it is 7 into 7, which is 49. Okay. Now let us update this with 49. Okay. Now out of 8 and 7, which is smaller? 7 is smaller. So now what I will do, I will decrement the right pointer. Now if you see between 8 and 3, which is smaller? So 3 is smaller. I will take 3. And what is the distance between them? 7 minus 1, which is 6. 6 3s are 18. So it is less than 49. So I don't update. Now what I will do, I will check which value is smaller. 3 is smaller. So I will decrement the right pointer. Now if you see, both are 8s. So both are 8s. So if that is the case, what is the minimum? Minimum, anything you can take 8. And what is the distance between them? 6 minus 1, which is 5. So its value is 40. So 40 is again lesser than 49. So I don't update. Now you can increment the left pointer or decrement the right pointer. That really does not matter. So now what I will do, I will simply decrement the right pointer. Now between 8 and 4, 4 is minimum and the distance between them is 4. It is 16. Correct, right? Now it is less than 49. So I don't update. Now between 8 and 4, which is smaller? 4 is smaller. So I will decrement the right pointer. Now again 8 and 5, 5 is smaller. Distance between them is 3. So it is 15. So I don't update. Now I will check 8 and 5, 5 is smaller. So I will decrement the right pointer. Okay. Now again between these two, 2 is smaller and distance is 2. So it is 4. So I don't update. I will remove. Now I need to decrement this pointer since 2 is smaller. Now between these two, 6 is smaller and distance is 1. So it is 6. I don't update my max value and I will leave this. And between these two, which one is smaller? 6 is smaller. So I will decrement my right pointer. Now if you see, both the pointers point at the same index. If that is the case, I'll stop here. So now if you see, we got our max value, right? So this we were able to do in single iteration. So we only scanned all the element at once, at most once. Okay, right? And then we got our maximum value. Correct, right? So this is the most optimal way. Let us try to write the pseudocode for this. Now Now what I will do, I will say my left pointer is at 0, my right pointer is at n minus 1. N will be length of our heights array. Now what I will do, I will take another variable, I will say max equal to 0. Now with this I will say while my left pointer is less than right pointer, what I will do, I will find the area equal to minimum of height of left comma height of right into right minus left. Okay, so this will give us area. Then after that I will update max equal to math dot max of max comma current area. This is same. After that we need to eliminate the lower value. So I will check if height of left is less than height of, I will say less than or equal to height of right, then what I will do, I will simply eliminate my left value. So I need to increment my left pointer. So I will say left plus plus. If that is not the case, in the else part, I will simply decrement my right pointer. Okay, so at the end, what you can do, you can simply return your max. This way, using this two pointer technique, I mean this is a standard example for two pointer technique which we have already discussed in our two pointer introduction video. So we can improve or we can boil down the time complexity from O of n square to O of n. So with only single iteration we found our max value and space complexity is of order 1. Okay, so with that let us try to execute this and see. What I will do, I will keep these things below. Int max equal to 0, then I will use int left pointer which is pointing to 0 and then int right points to n minus 1. Then I will use a while loop. While my left is less than right, what I will do, I will first find the area. So the same formula we can use to find the area. Then I will remove this unnecessary part. Okay, after this what I will do, I have just formatted it. So after this I will check if my height of left, if it is less than height of right, then I will simply eliminate my left value. So it means I will increment my left pointer, else I will decrement my right pointer. And finally I will return max value. Now let me run and see. I have missed semicolon. Now our solution got accepted. I will submit. Our solution got submitted successfully. So this is how we optimally solve this particular problem in O of n time complexity, basically linear time complexity with constant space. Okay, so hope you liked the explanation. If that is the case, please consider subscribing to my channel and also like the video, share this video with your friends. And if you have anything that you want me to solve, you can add that as a comment. And also if you have understood it well, you please add that as a comment as well. Thanks for watching.